Process engineer Joe operates a Levitronics pump in flow control mode. His process requires frequent changes of flow rate set point, but his system reacts too slowly to keep up with the changes. How can Joe make the system more reactive? The answer to this question lays in PI tuning. In flow control, the controller compares the actual flow against the set point flow and calculates their difference, called error. Based on the error, the controller calculates how much the pump speed should increase or decrease. The controller determines the change of speed by adding up two terms. The first is proportional to the error and is dominant at the beginning of the transient because the error is very large. The proportional term is multiplied by a constant factor called p-gain. The second term is proportional to the integral of the error over time, and it is dominant at the end of the transient because the reaction to an error builds up as time passes. The integral term is multiplied by a constant factor called I-gain. If the response to the setup input starts too slowly, it's necessary to increase the p-gain. If the initial response is fast, but there is a persisting error at the end of the transient, the I-gain must be increased. If the response overshoots or oscillates, both gains must be reduced. By tuning the PI gain parameters of the control loop, Joe is able to make the system more reactive. Levitronics, better pumps for better yield.